And now let's take a look at the problem number 6. Assuming the concrete slab with the following attributes. So these are the attributes, right? And then using this, so basically, what is the, let's see. So the problem number 6 asks you to, using the coefficient in the model, what do you predict the slab's comprehensive strength to be? Okay? Okay, there are a couple of ways to do this. You can do it manually. Okay, so now, also it's very important for you to know how you can do it manually. Okay, so you know that we have y is equal to mx plus b. So this is very typical, a very simple linear regression model. Y is the dependent variables, and m is the independent variable coefficient, right? And x is the independent variable value, and the b is the constant, right? In a set. But we know that we have a lot of independent variables, right? So for example, let's just take a look at this table, right? And so now let's take a look at this table. Okay, so if you look at this table, so you have a coefficient for each model. For example, right? Let me just write this down. So for this, hold on. Okay, for the cement, right, it's 1.06. Okay, for the cement, yes, the coefficient, right? The coefficient is 0.1067, right? Let's use the and then slag. What is the coefficient? It's a 0.0913, and then the fly ash, it's 0.0751, and the water is negative 0.2302. And then super, plasticizer, right? It's the, let's just call S, and then it's 0.2376. Age is 0.1253, and the constant is 30. The constant is 30.0141, right? So that's the value. Okay, now let's go back to the problem. So the manually, right? You can find the y value. We can predict the y value, right? So let's just write the formula, right? The y is the coefficient, right? So that's for the cement. The coefficient is 0.1067 multiplied by the value is 400, right? Plus the coefficient for the next slag is 200, right? So equal, the plus, and then there's a coefficient, right? 0.0913 multiplied by this value, 200, the plus, and then now what? The fly ash is a 0.07, 0.0751 multiplied by 10, right? And etc., right? So if you just finish everything, right? And then, the last is a constant. So the plus, we just do this, and then the last thing is plus, and then we need to do the constant, which is a 30, right? 30.01, 30.01141. Okay. So once we calculate this, your y value is what? The predicted value, target value is a 69.192. Okay. So this is like one way. However, the correct answer, there is a correct answer 6.9177, but there is a slight difference because, for the manual computations, you use what? You use rounded coefficients. But for freehand, it applies the full unrounded coefficient when it makes the prediction. So this is the actual value when you use in the Python, and this is like your manual, computation. There is a slight difference, right? It's just slight difference because of the rounded coefficients, right? Okay, but anyway, so this is like one way. I want you to know this way. The manual is very important, right? Manual way. And then this is like, you can also use Python. right? Of course. Another way you can use it is using the Python code. Use the predict functions. Okay. Then you provide this value 400, 210, right? 400, 210. But make sure that the order of the order of this values are important because when you train the model, right? We use this orders, right? Cement, slag, right? We use this order, right? So let's just write this down. So the order that we use is what? The cement, slag, the fly ash, water, and then super. Then we did not use this, and then age, right? Okay, so this is in this order. So the order is very important, right? Okay, so when you look at this functions, the predict functions, right? Where is it? Okay, so when you use the predict functions, make sure that you're using this order, right? So okay, okay. So first cement, and then S, F, water, S, and H, right? F, water, yes. Water, yes, S, and then H, right? So how many of them? 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, and 6 of them, right? So in that order, right? So make sure that, okay, so 400 cement, then flag is 210, 150, 10, and 77. And then also another thing, when you use a predict, make sure you use a double brackets. You see the double brackets here? Okay. So when you run this, let's just run this, okay? You will get this value, right? Which is close to your manual, computations. Okay. The warning that I'm asking is that X does not provide a valid feature name, but it's fine. This is warning. Okay, so in real, we have to provide the name. This right. This for the cement. This for the slag. But they're complaining that if you look at this, that we did not provide the the label. I mean the column names. That's what they're complaining. It's fine. Feature names, right? Column names. Okay, but this is fine. It's just warning. That's the value. Okay, so there are two ways: manual way, and another way is you can use a Python code. Okay, there are two different ways. Okay, so that's a problem number 6. Problem number 7 is that assume the concrete slab with the following value. Using the coefficient in this model, what do you predict the slab's compressive strength be, right? Okay, but this problem, right? Where is the okay? So for this problem, let's look at the problem number. Is that problem number 7, right? Okay. So now let's take a look. Problem number 7. Yes. In that case, using the coefficient in the model, what do you predict slabs compressive strength to be, right? The predicted value. Okay, so first what you have to do is you have to be very careful. First, you have to make sure that okay, so you have to make sure that this value, right? Let's see. Oh, basically you can ignore these two independent variables. We do not use these two variables for training, so you can completely ignore. You don't have to. I mean, this two actually. Sorry. You can completely ignore these two values because we do not use them for training, right, in our model. Okay, but however, you need to look at this value. Is this value 525? Is this value fall between the mean and max of the values in the training data set? Okay, so for example, so 525, right? So you have to 525 Just go back to the training. Yes, that's the hold on. Yeah, that's the value, right? That's the hold on, training. Not to predict. Yes, this is our training data set, right? The concrete, break, breakage, right? That's our data set for training, right? So what is the mean value? Is 102. The max value is 540. 102 and 540. I mean, you have to do, actually, you have to do the same thing for the question number 6. Okay, but let's say question number 7, 525, right? So let's see. Where's my pen? So 525 is less than the mean and max of cement column in the data set. What is the hold on? What is the mean? Mean value is hold on. Forgot. The data training data set, not the scoring. Okay, so this one, right? This one is our our training data set, right? Training data set, training. Yep. Hold on. Okay, package. Okay. Okay, so this is our training data set, right? It's not the scoring data set. So the mean is 102. So the 102, and then 540. Yes, so there's no problem. For the slag, what is the mean? By the way, this is the data, that's for the training data set. It's not the scoring. And then the slag is what? From 0 to 359. So 0 and then slag value should be between this value, mean and max, 359.4. Okay? So let's go back. So that's the question number 7, right? So the slack value is what? The slack value is 108, right? Oops. Oops. Anyway, hold on. Slack value is 108. You know what? Can I just undo this? Probably not. Okay. Oh, this is undo. Good. I have undo. Okay. So the 108, right? So 108. So 108 is greater than 0 and less than 359. So that's good. So you have to go to each value, let's say 525, 108, and 112, and then 10 minus, is it 10.87, and then 0, and this one we can skip it, we don't use it, and then H224. You have to go to each value and make sure that this value really falls into the mean and max of corresponding column, right, in the training data set. Okay, so hint is look at the training data set, but not the scoring data set, and for each column, look at the mean and max. Okay, look at the mean and max, and whether this value, right, fall between the mean and max, right? So that's something that you have to do. If that's not the case, then what answer can be? Answer can be what? They cannot make the prediction for the slab using this model. Okay? So please check. Okay, that applies for the actually problem 6. You have to check. You have to look at the mean and max. Okay. Same thing for the problem number 6. You need to check this value, right? Make sure that this value really falls between the mean and max of the corresponding column in training data set. Okay, not the scoring data set. Okay, the problem number 8. Let's look at problem number 8. Okay, by the way, this is not the answer. I just want, but the problem with this thing is once I just click it, I cannot, you know, I cannot remove this check. Anyway, okay, problem number 8. So problem number 8 is what? In the training data, no slab achieved a this y value, right, above 50 without curing for at least 7 days. Yeah. Using this linear regression model, so basically what is the minimum number of days for the concrete slab would need to cure in order to achieve predicted, a y value above 50, right? Compressive strength above 50, right? Okay. There are many different ways we can solve this. First, we need to find the rows whose y value is greater than 50, right? This value is greater than 50. And so definitely we need to use a Boolean expression, right? There are many different ways. But one way to make the data frame containing only those scoring observation with the predicted strength value is greater than or equal to 50, then you can find the minimum age, right? So the cure means you have to look at the age column, right? Okay. So there are many different ways, but one, obviously you need to use the Boolean expressions, right? This is the data subsetting, data frame subsetting actually, right? So in the concrete strengths predict, look at the predicted strength column, anything that greater than 50, you will store them in this variable strong 50. Okay, you can use different variable, right? And then you can look at the age column, and then you can apply the mean functions. Okay, so you know what? So if you look at this strong 50, right? Let's say print in strong 50, right? Okay, so when you print, let's just first print this guy. Okay, so you see that it shows, right? It shows all the rows whose predictive strength is greater than 50, as you can see, right? If you look at this, 51 is greater than 50, right? Okay. Okay, so then among this, right, now we can look at only the age column, right? This will show the only age column, right? Just the age column. Oops, print. Right, this is only shows the what? That. Okay, it only shows the age column, right? Okay. Then we can apply the min to this. Okay, the strong 50 dot age. Then we can apply the min functions. Okay. So let's just print. Oops, this is strong. Oh, spell age. Okay. So at the end, it will show this is the answer, right? This is minimum value. Okay. So the minimum age value. Okay. So you can find the answer. That's a problem number 8, right? So that's like a minimum age, right? Find the minimum age, right? Okay. And the problem number 9. Okay, now let's take a look at the problem number 9. The problem number 9 is that this predicted to be the weakest concrete in the scoring data, right? And what, compressive strength is that the slab predicted to fail. So, I mean, once again, there's a lot of ways you can solve this problem, right? One way is sorting the scoring data on the projected strength in ascending order, right? So really like starting from the lowest. Okay? Then because you don't have to look at everything because you only look at the first few lines because I need to find the weakest concrete, right? Okay, so you can apply this, right? So anything below this, they're gonna fail to predict, right? This is like the smallest predicted strength. Anything below this, slab predicted to fail, right? Okay, so that's the question number 10. The question number 10 is how much variability in the y value is explained, the target value is explained by your linear regression model. Okay? And you know what? This basically asks you to find the R square value. Right? I think you can find the R square value in the summary table. Okay? So thank you.